In this video, we're going to cover 1.5 data organization. And this is split into two sections, data structures and file design. We're going to start with data structures, and data has to be stored in any program for it to do something useful, and correct data structures are equally as important as the correct data type. And the three main structures are one-dimensional arrays, two-dimensional arrays, and records. Arrays can only store one data type. For example, it will only contain integers, strings, real numbers, characters, but it cannot contain a combination of them all. Each variable in an array is called an element, and each element's position is known as an index. And it's important to note that indexing mostly starts from 0, but the exam syllabus may start from 1 in some cases. Here is an example of what a one-dimensional array looks like. There is a variable called names, and it's storing these 5 separate names, and they've all got their own index starting from 0. And this makes it easy to access or change data later on, and each element can be referenced directly by its index. For example, names 4 equals Jane. Two-dimensional arrays are like a table and have a double index, one for the row and one for the column. So names 0, 0 would equal Sam. A record is a set of data items all related to a single entity, and a record is different to an array as it can only contain more than one data type. It's not restricted to a single data type. The example on the right shows the sort of data structure for a record, and you can see it contains different data types. We may also need to calculate the space needed in bytes, and we do that as follows. We add the size in bytes together, and then we can multiply it, for example, by 100 if there are 100 records in the file, and this means that we need 6,100 bytes. The second part is file design, and we need to know 3 key terms for this section. A field, which is a characters grouped together, a record, which is a collection of related fields, and a file, which is a collection of related records, has a file name so we can access it later on using that file name. Data on computers is stored in files, and they always have some sort of structure. Records store all information about an object, and fields store the data that this information is made of. For example, this could be an ID number, it could be a name, a quantity, etc. But these can be different data types. And in the example on the screen now, you can see that the first row is called a record header, and then each row is a new record, and each column is a separate field within that record. Fixed length records have the same number of bytes in each field and record. They are easier to program because we can calculate exactly how much storage is going to be needed. They're quicker to process by a computer because we know where the start and end locations are. It does waste storage space because some fields might have lots of blank spaces if they don't take up the whole space allocated. But truncation can take place due to the fixed size. So we can limit the gender, the date of birth into specific formats to save space in the computer. Here is an example of how it may look. We have the data, and each end of field is marked with the asterisk, and then we can mark an end of records with a hash. Alternatively, we can use a character count to specify that the next so many characters are part of this one field, and then again using a hash at the end to identify the end of the record. A computer operating system needs to know how much memory to allocate for the file, and we estimate this by multiplying the number of bytes in each record by the total number of records. And if we take that to an example here, the size of one record here would be 62 bytes if we added them all together. If we multiplied that by 20 for 20 records, we'd get 1,240 bytes.